Good morning, everyone. I think we are ready to start. Okay. I know today you were supposed to have a lecture with Dr. Vambadzikos, but we will do it together. Last time, we had seen how we can run a scenario-based seismic hazard analysis, and we visualized the outputs with QGIS. We will continue with that for now, and then we will see other type of calculations. I would like you to open your QGIS file from last time and to open also OpenQuake in order to use it later. Let me share my screen. First of all, can you hear me? Could someone please answer?
Yes.
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 Yes, we
Very
can hear
much.
you.
I think you can see my QGIS screen.
Yeah.
Okay. That's perfect. So last time we said that we were running an SSHA analysis, and the first thing we did was to use a truncation. We had a specific fault with a well-defined rupture, and we said that we wanted to produce 10 ground. Hello again. My internet connection is cursed. I'm sorry for that. Okay, so we are back. I think everything is okay. Can you hear me now again?
Yes, we can hear you.
Yes.
I'm so
Yes.
sorry for that. So where did you lost me exactly?
At the beginning, where we started by opening the files that we ran the last time.
Okay, thank you very, very much. So, okay, that's perfect. That's amazing. What we want to do now is to open the folder we ran last time for our scenario seismic hazard analysis. This is what we had, where we had set a truncation level equal to 0. Right now, we want to run again the analysis by using a truncation level equal to 3. So you can copy paste this folder, copy paste it, and rename it in order not to confuse the outputs. If you cannot rename it. Open it, and over here we will change the value from 0 to 3. If you remember, in order to run the analysis, we have also to zip the folder. And now we have to open our OpenQuake engine and run the analysis. Go over here, run a calculation, select the folder you have just made. I won't do that. And perform the analysis. Well, it's not bad, I can do that too.
Could you tell again the changes?
Of course. The only thing we want to change for now is the truncation level in order to see how the outputs will change from last time that we used a truncation level equal to 0. This is this line over here, truncation level equal to 3. Then
Okay.
you close the folder, you zip it, and you run the analysis.
Okay, thank you.
You're welcome. I think my analysis is done. If yours is too, we can also remember that If you press outputs, over here you have what OpenQuake gave to you, and you have to download ground motion fields. It is a CSV file, so download them and save them where you want to save them. I have them over here, so I'm going to unzip them again and open my QGIS folder, my QGIS, and visualize them. Do you follow me? Do you need some more time? Okay, let's see how we can visualize a ground motion field. We are going over here and we will add a delimited text layer. Over here, we will find the file we want to visualize. This is from last time. I will find the file that I want, and the first thing is to choose the site mesh. If you remember, this is a CSV file, and on the geometry definition, we are using point coordinates. On the x-axis, we have log, and on not axis, field, and on the x field, on the y field, we have the latitude. Click add, and we have the mesh of our site. The next thing,
Can I ask
yes,
you something
of course.
about the data source manager and the delimited text?
Of course.
When I insert the file format, if I choose the CSV, I can see separate the columns of the Excel, and only with custom delimiters I can see.
I think that last time I showed you how you can convert CSV data to columns.
Yes, I convert.
If you did that, okay.
I convert.
If you did that, then you have to use another delimiter. But if you select the file as OpenQuake give it to you, you don't have to. I only showed you how you can do that because today that we will run another type of analysis, we will use those data. I'm sorry, I had to tell you.
Okay, thank you.
You're welcome. The next thing we have to do is to insert our ground motion field data. The same way we did for the site mesh, we have to insert this file. This is also a CSV file. If you have changed the Excel, then use another delimiter. But in this case, we are using no geometry. We have said that in this case, we don't have the coordinates, but we have the site ID. Okay, I will add that too. Before we join the layers, in order to see the outputs, I will filter the first ground motion field in order all of us to have the same outputs. I right-click on GMF data, and if you want, you can rename your layer. You can do that in order to know what we are seeing. So I have a ground motion field data. The first one for PGA values and a truncation level equal to 3. I will also filter the outputs. Again, I will right-click, select Filter, Event ID, and Operator as equal, and I will select 0. Now, over here, I see that my ground motion field is filtered. The next thing I have to do is, as I told you, to join the layers. Right-click on Site Mesh, go on Properties, choose Joins, and add a new join. Over here, you see the last layer we used. We have to change it and select this one. Use side ID twice, and now we have joined them. You will see that over here. Go on Symbology, choose Graduated Values, over here we will select the value we want to see. We said that we want a ground motion field for PGA values, so we will select that over here. I want a spectral color ramp, and I will invert this color ramp. On the mode, we are using equal interval, and we can let 5 classes, we can change it. The only difference is that our outputs will be a little smoother. Click on classify, don't forget always to click on classify, apply, and OK. And those are our new outputs. If you remember, last time we had this, and right now we have this. If you want to not to see the outputs, just click over here. Okay. I know that the outputs are totally different, but you shouldn't be very stick to the outputs, to the colors, not the outputs, because as you see over here, if you click on this button, you will see that now our intensity measures, our PGA values are way higher. This is because we have used the truncation level equal to 3. That means that we are taking also 3 standard deviations. And last time, we are using only the mean value. Are we okay so far? Have you done it? Okay, I think we are okay.
Can I ask something?
Of course.
I tried to put the scenario seismic hazard in
Yes.
with the new tranquilation, how we call it,
Truncation level.
truncation level, but the OpenQuake doesn't accept it in the site. It puts me out a code and something that cannot run it. Don't know what.
Oh, it probably says you something, but if you want, you can share your screen in order to
Yes.
see what is the problem.
Let me see. Okay, share screen. Okay, you see my screen.
Yes.
Okay, I have the folder here.
You haven't zipped your folder.
Yeah, I do it a zip file.
Oh, please don't do it
Yeah.
like that because this is a RAR file. So just say right click on the folder,
Yes.
use the option Apostoli Pros, or in English send to Apostoli Pros.
Okay. Yes.
And use a zip file.
Okay. That was my problem.
Okay.
Yes. Okay. So
This is common. Don't worry.
stop sharing. Okay. Thank you.
You're welcome. I will continue sharing my screen. Okay. So we were over here. I think there is a. Okay. That's probably on the chat from before. And the next thing I want you to do, all of us to do, is now to use also the spatial correlation model we discussed last time. We will do it again the same way. We will copy paste this file, this one over here. I will rename it. I have already done that. I know that I have a scenario SHA with a spectral correlation model and the truncation level equal to 3. In that folder, I have to change my configuration file, the job.ini file I have. And over here, if you remember, we have used hashtag signs. That means that those lines were comments. So if you delete them, now OpenQuake will use them. Okay, save that. Also zip that folder, send to zip, and now we will run our analysis with OpenQuake again. Back to calculations, run a calculation, select the folder you want, and the analysis is running. We will wait for a minute. If you have any other questions about the program or anything, you can ask me.
Okay.
The analysis is done. Again, you know, we are downloading the outputs for the ground motion fields in our computers. Okay, I did that. And we are going again on QGIS, unzip over here, and go on QGIS. And again, add the delimited text file layer. First, we are plotting the site mesh. Let me go on my results. The first thing is the site mesh. Don't forget to change the geometry definition. We have point coordinates over here. Add it. If you see, I would expect that, and I'm seeing that. Next, we want the ground motion field data. Select the two. This is a no geometry text file. Select that. Now I can see over here.
Wait.
Okay. I will rename this layer. Right click on it. I want to remember what I have done. I will filter the first ground motion field. I want the PGA values. I have a truncation level equal to 3, and in order to remember, I will also write that I have correlation. Okay. I have to filter the outputs for the first ground motion field. I'm using the first ID. It's over here that my ground motion field is filtered. And I have to join the right click on properties, joins, adding a join. Don't forget to change over here the layer. We are selecting site ID twice and click OK. Okay. Then click on symbology. Use graduated option. And we are using also this option over here for the values we want. I want a spectral color.
Sorry, I have the mic open.
Okay, no problem. Invert the color ramp. Use an equal interval mode. Classify. Apply. And now we're... So let's see what we have so far. From here, truncation level equal to 0. Then we use the truncation level equal to 3. Our ground motion field was kind of messy. And over here, we have also a spatial correlation model. We see that the outputs are have more common sense, I could say. We can see a map, a ground motion field that makes sense for me, at least. We are starting from higher values, and then we're going to lower values of PGA. And that was our scenario seismic based hazard analysis. If you don't have any questions, I will save this file. And I won't close my QGIS because we will use it also later when we will visualize our hazard maps. Right now we will with another calculation and type of analysis with OpenQuake. So before I leave from that part, do you want to make any questions? Is it something that you don't understand? Any problem with OpenQuake or QGIS? Anything? So I think we are okay. Perfect. As I told you, we are continuing with the classical PSHA analysis. Okay, why can I see that on full screen? I guess I have to stop sharing and share it again. I will do that. Confusing. Stop sharing. And I want to open this file. That's perfect. That's not perfect. Okay, we will see that like that. So, when we are running a classical PSHA analysis, OpenQuake, not OpenQuake, a classical PSH analysis produces as outputs hazard maps, uniform hazard spectra, and hazard curves by solving the PSHA integration equation which you have seen already with Dr. Van Vaticos. You have discussed it so far, but we can see it a little fast. So, we have an area we want to study. And in that area, we have to identify all the seismic sources. For each source, we have a distribution for the magnitudes. Each source is associated with a distribution like that. Using our ground motion prediction equations, the magnitudes and the distances from our site, we now have the intensity measure types we want. PGA, spectral acceleration, it could be also PGV, whatever we want. Having those inputs, classical PSHA computes the probability of exceedance at a given time span and at a given area for a set of ground motion intensity measures. So, for the intensity measure I want, for a set of intensity measures I want, classical PSHA will compute the probability of exceedance at a given time span. Over here, we see the parameters you already know. We are using all the distances, all the magnitudes for each source. Those are the seismic sources. And we are taking as an output the probabilities of exceedance. The basic thing we have to keep in our minds is that we are using all the seismic sources, all the ruptures on our search model. So, in order to run the analysis, we are using our search model with distributed and seismicity on faults. We are having also ground motion prediction equations, and we are using OpenQuake in order to have our hazard maps back. Those are hazard curves and uniform hazard spectrum. We will have the opportunity to run our own classical PSHA analysis and to produce those outputs. This is the calculation workflow, but I prefer to discuss it later. For your term project, I think that the second question is to perform this type of analysis, so you will do it again and again until you will be able to do that on your own. We will together all do that until you will be able to do that for your term project. So, as last time for our SSHA and SSH analysis, also here we want a configuration file. This is the job.ini file where we're making our changes. First, we are giving a description. This is a file for classical PSHA. Over here, we have to change the calculation mode. Last time, we had a scenario-based analysis. Over here, it is a classical, so we have to set it equal to classical. As we have said, the random seed is in order all of us to have the same outputs and we can discuss them. I think I should zoom in a little bit. Also, the first thing we are doing is to define the region or the site we want to study. If the area we want is a region, as on your term project, we're selecting this option. We are giving as inputs the coordinates of the polygon we are using for the site we want to study, and also we are using a grid where we define the spacing of each point. In this case, we are using 10 kilometers. We could also use a specific site or sites. You have also to do that for your term project. If you remember, if you have read that, for the first time, at first you have to run a classical PSHA analysis for the whole settlement you have chose, and then for the center of that settlement. If I want to study the hazard of a site, as I told you, I'm giving the coordinates over here, or if I have many sites, I can give as an input a CSV file. Okay. Let's go over here. I'm sorry. Let's forget them for a second and go over here. Now that we have defined our region, we have to give the parameters, our area anyways. We have to give the parameters of the site. We have said that we are using the VS30 value. VS30 is the average shear velocity at the first 30 meters of our soil. We are considering that every point of the site we want to study has the same VS30 value, and it is equal to 760 meters per second. Those commands over here are associated with the ground motion equation, prediction equations we use, but this is more for our seismologist friends, so I don't want to say anything more. And let's go back over here. So far, we have defined the area we want to study, the parameters of that area, and the next thing we have to do is to discretize our seismic sources, our seismic sources, yes. Over here, we are giving the mesh of the rupture. If you remember, this is a fault, this is the rupture of the fault, and we are using a mesh of 5 kilometers. Each source is associated with the distribution of the magnitudes, so we have to specify also the width of the bins for each magnitude. In this case, it is 0.1. Also, we don't have only faults, but we can use an area search discretization. Do you remember the distributed search we saw last time? In this case, we are using 10 kilometers distance between each point. Okay, for that. So we have defined the area we want to study, the parameters of that area, and we have discretized our source models. Remember that the lower those values, the more precise our outputs, but also the higher the computational time. Also here, we see that we have to define the number of logic tree samples we are using. In this case, we set it equal to 0. That means that we will take into account all possible realizations of the logic trees we will use. We will see the logic tree files that we will use for this analysis, so don't worry, we will understand them quite well. The next thing we have to do is to give as inputs the logic trees. If you remember, last time we said that we are using logic trees in order to keep in mind all the epistemic uncertainties for the source model and also for the ground motion prediction equations. So we are using two separate files. The next thing we have to do is to specify the maximum distance. In this case, we are using 200 kilometers. If this is the distance between the site we want to study and the faults that produces ruptures, that produce earthquakes. And then we have to specify the parameters for the analysis. Those are the most basic parameters. Classical PSHA computes, I think there is a grammar here, yes. Classical PSHA analysis, PSH analysis, to be more specific, computes the probability of exceedance for a given time span, in this case 50 years, for a set of intensity measure types. In this case, the intensity measure types I want is PGA, and I'm giving a set of points of PGA in order to know the probability of exceedance in 50 years. Not the annual probability. In this case, I want the probability of exceedance in 50 years. If I want to produce an output like that it is called a hazard curve, then I have to tell OpenQuake that I want the mean hazard curves and set it equal to true. Remember the mean hazard curves. We can also use quantile hazard curves. If you remember from your statistics, we can use a percentage that we want, 10, 15, whatever. And remember that 0.5 quantile hazard curve is exactly the same with the mean hazard curves that we will produce. Okay, I'm sorry. Sometimes we may not want the hazard curves to show us the probability of exceedance in 50 years, but we may want to know the mean annual frequency. What is mean annual frequency? Okay, let me click on that comment. No, doesn't let me. I will write it also on the chat later in order you to see that. Okay, I will write it on the chat. Please let me see that. Ah, that's perfect. Okay. We have the probability of exceedance for a given time span. If we want, we can have a time span of a year. In this case, we will take back the annual probability of exceedance. This is up to us. I'm sorry for a minute. Okay. For really low values of annual probabilities of exceedance, that's values lower than 0.01, those values are almost the same with the mean annual frequency. And let's explain what the mean annual frequency is. Let's consider that we have an earthquake with mean annual frequency 0.01. That means that on average, that's we are saying mean, every year, that's where we're saying annual, that an earthquake with magnitude that to 100 years has a probability 0.01 to happen. Okay, you understand the probability of 0.01, but where does the 100 years came from? This is the mean return period, that it is 1 over the mean annual frequency. So let me repeat that, because I remember the first time I heard about mean annual frequency, I didn't get it. If I have an earthquake with mass equal to 0.01, that means that on average, every year, I expect an earthquake with magnitude that corresponds to 100 years to happen with a probability of 0.01. We'll see also later when we will run our example, so don't worry. We can also have uniform hazard spectrum from open-quake. You remember that a uniform hazard spectrum gives us the spectral acceleration for a range of periods at a constant probability of exceedance in a given time span. Over here, if we want uniform hazard spectra, we have to set it equal to true. Also, we can ask OpenQuake to give us hazard maps, also specify here equal to true. And if we want a hazard map of a PGA hazard map for 10% probability of exceedance in 50 years, over here, we have to define the probabilities of exceedance. In this case, 10%, and don't forget the investigation times is 50 years. First of all, I think it's time for a break, but before we go on a break, I have to tell you that after the break, we will perform our analysis, and if you have any questions, you can ask me. Now or later. Are we okay with that? Are all of us okay with that? Do you want a break? Do you want to continue? It's up to you. Nothing. So let's have a 15 minutes break and we will come back. Okay, I think we can start again. So we have left in the part that we will run our demo, our classical PSHA demo. In order to do that, we have to download the files from my courses. Before I do that, let me share my screen again. Okay, so please go on my courses and on documents, you will find the OpenQuake files. From that, please download the classical PSHA folder. I have already done that, so I have it over here. Unzip it and let's discuss what we have in this folder. Over here, we see that we have two files for the logic trees two others for California and the configuration file. I will open them with Notepad++ in order to see them very well. The first folder over here that says California Grid.
Excuse me, Angeliki. Could you please go a bit slower because we are still downloading? I'm sorry.
Okay, of course.
Sorry.
Don't worry. So I'm saying again that in this folder, we have other files. Those must be in it in order to run the analysis with OpenQuake. Okay. If I would like first to open this file over here, and we can see that in here, I have a set of point sources for each point of my grid. If you remember from last time, we did the same, we saw the same thing for point sources in the introducing of OpenQuake. So we have the upper and lower seismic depth, we have the bin width, the mean magnitude. Folder given to us. You don't have to do it on your own. If you see it is a huge file, you couldn't possibly do that, even if you want. So we take that as granted. We have also another file over here that is for California and says fault. If we go on this file also, we will see that over here we have simple and characteristic faults. I think there are only these two types, I'm not sure, of course. This is also a huge file where someone else was so polite to give this to us and to have specified for each fault. Press over here, you will see that each fault has its characteristics also. We have the dip angle, the orientation, the upper and lower seismodepth. You remember from last time, this is exactly what we have done in our SSHA demo from last time. Also, this is given to us, you can't do that, only seismologists would be able to do that. And then we can go to our logic tree files. Let's go over here. We have the logic tree for each model. We have set to OpenQuake that we are using only one seismic source, where we have specified we are using only one file, where we have specified all the faults we want to use. Remember from last time, we are taking into account all the possible uncertainties from that file. We are having logic tree files for the ground motion prediction equations. Over here, we will use 3 GMPs, each one of them with its weight. All those files are an input in OpenQuake. The only thing you have to change is on the configuration file. We are always making changes in here. So let's take it from the beginning. Okay. We are giving a small description. We will run a classical PSHA for California using a fault selection. We have already seen the fault selection. It is huge. We know that. We have to specify the calculation mode. It is classical. And we are using a random seed. We don't care about that. The next thing we have to do is to define the polygon, define the coordinates for the area of California. Those coordinates are given to us and we are using a map over here, we will be able to see that map in QGIS. We are also giving the grid spacing. In this case, we have 5 kilometers. Ignore that for now. Before we go there, let me read what we have to do. We have to produce PDA and spectral acceleration hazard maps for 63 and 2% probability of exceedance in 50 years. So we will run our analysis for California, and we want to have hazard maps as an output. Over here is the area of California. We are taking into account all the uncertainties in our logic trees. We have the discretization of our Seismic Sources. We don't have to change anything here. Next, we have to specify the site parameters. If you also see over here, the first time we will run it for a VS30 value of 760 meters per second. And if you want, you can repeat this calculation for another value. And then we have to give as inputs the .xml files we just saw, the source model logic tree and the ground motion logic tree.xml file. Those are our inputs. We said that we want to produce hazard maps for 63 and 2% probability of exceedance in 50 years. Over here, we have to define the investigation time. This is in years. And we want, and over here, we define the probabilities of exceedance. So 63 and 2% in 50 years. We are okay so far. The next thing we have to define are the intensity measure types. If you remember, hazard curve we saw before, we are giving as an input a set of intensity measure types, and we want the probability of exceedance. So over here, we give a set of values for PGA, another one for spectral acceleration at 1 second period. The next thing we have to do is to define the truncation level. As we did on our SSHA, we use a value of 3. And then specify the maximum distance. This is 200 kilometers. Okay. The next thing we want to do, I have changed the name of my exposure dir. You can write whatever you want. I have write California outputs. And I want to produce hazard maps, so we have to set it equal to true. And also you have to set mean hazard curves equal to true if you want to produce hazard maps. Uniform hazard spectra are defined as false because we don't want them for now. And also I think we don't need to produce also quantile hazard curves, so please make it a comment. Do you have any questions on that folder so far, on that file? Okay, so save that. And let's go back. We have to select all those files and zip them. This is my classical, this is my probabilistic seismic hazard analysis. And we have to open our OpenQuake and run the calculation. So click on Run. Find the folder we have just made. Let me find it. Select it. And our analysis will run. I think that on the folder you have, the name of the configuration file is job classical. I think. If you try to run it, you will see that OpenQuake will complain. You can use only names as job.ini file, job/has, or job/hazard. I prefer to keep only the job name in order not to get confused. My analysis is running, and I hope yours too. This takes almost 3 minutes, I think. So we have plenty of time if you want to discuss something. Do you have any problem running your analysis so far? I guess not.
On it shows calculation not accepted traceback. What does that mean?
Would you like to share your screen in order to see that? That's OpenQuake complaints. It gives us a traceback.
Still, once again, I'm using another computer than the one that I'm using with. I'll give it a try.
Okay. Could you describe us what this traceback tells you? I'm sorry. Have you changed the name of the job.ini file? This could be.
Yes, I did. All it says is calculation not accepted. Traceback. That's what it says. Should I click on traceback? No.
Yes.
It will not let me to click on traceback. I have sent it to the job file.
Okay.
Can I send the zip file to your email and see if you can see something?
Of course, yes. My analysis is not done yet. I guess yours too. Okay. Wait for a few seconds more. Is anyone else that took a traceback from the analysis? Or it is running okay? I guess we are all okay. I'm sorry, could you please say it again a little louder? I can't hear
I
you.
haven't renamed the file, the job file, but somehow it works. The analysis is done. Everything's fine, I think.
It says job classical? Impressive. At least on my computer, it gives me some traceback sometimes, but it's okay if you can do that.
Okay.
Well, my analysis is just finished. So let me share my screen. And let's discuss our outputs when yours is probably running Okay, over here we have the full report of our analysis. We don't need that for now. We have the hazard curves and the hazard maps. We will see hazard curves later, but now the most basic thing we want to see is the hazard maps. So I would like you to download the CSV outputs on your computer. I will rename it. And over here, I have my outputs. Let's open it. Ignore that. So I have a column for longitude, latitude, and then OpenQuake has columns with the probability, with PGA values for 63% probability of exceedance in 50 years. So in this column, I'm not changing the data from from separated by comma to columns in order not to confuse someone, but we will visualize them in QGIS and you will see how easy it is to understand what we are seeing now. So we have peak ground acceleration values for 63% and 2% probability of exceedance in 50 years. And also remember that I asked OpenQuake to give me also hazard maps for spectral acceleration at 1 second period for the same probabilities also. So let me close that file and open QGIS. We have to start a new project. I have already done that, so please do it also. As we did on our SSHA, we have to add a delimited text layer. So click on that, and we have to find the file we want. In this case, this file is what we have just downloaded from OpenQuake. So over here, we see exactly what we saw a minute before. This is a comma-separated file, and over here you see that I don't have the names of the columns, but I have something else that says me what are the fields. In order to skip that and get as names of the columns what OpenQuake gives me, I have to use as a number of header lines and to discard the first one. So I'm changing this over here from 0 to 1. From 0 to 1. The next thing I have to change is the geometry definition and to use point coordinates. This is because I have the coordinates and I want to produce a map. So if I click add, before I go, over here on geometry CRS, I don't know what it writes to you, but I have used this option. If you click over here, you can use the WGS 84. Select that option and you will understand why we are doing that. If it is okay, just leave it like that. So this is our California map, our California grid exactly. If you go over here, you have to select also the same coordinate reference system. If you do that and click apply and OK, now we can go over here that says browser, over here, scroll down and go on XYZ tiles. Are we all on the same spot so far? Do you follow me? Should I wait for a few seconds?
Sorry, I cannot find WGS option on Geometry CRS. Actually, it just shows invalid projection and project CRS.
Over here, you mean?
Yes.
Give me a second, because it's stuck. I will open it. Okay. Probably if you click over, if you write it over here, you will be able to find it. WGS 84.
Okay, thank you.
That's perfect. Okay, now we did that. Please go on XYZ tiles and double click on OpenStreetMap. What we see now is obviously an OpenStreetMap. And if I want my hazard map to be on it, please move that in order to be above the layer of the OpenStreetMap. You know, if we just click it, we won't see it again. So you see, we have a map of California, and it is exactly on the right point, on the right area. So do you see the hazard? I can't see anything. In order to do that, we have also to make changes. But before I do that, I will rename that layer in order to remember what I have done. Right click on it and you can change the name. I want a PGA hazard map for 63% probability of exceedance in 50 years. This is not 50, this is 50. Okay, so right click on that layer, go on properties. In this case, we don't have to join any layers, we have just one. So skip joins and go on symbology. We will use graduated, and the values we want for now are PGA values for 63 probability of exceedance in 50 years. I want to change the color ramp to spectral and invert this color ramp also. As we did before, I want an equal interval mode. I click on classify, apply, and now I can see my map. We can understand many things from that. So I would like, before we discuss about them, to do the same thing, but for the PGA hazard map for 2% probability of exceedance in 50 years. If you want, you can also add a delimited text layer, but you can also right click on it and duplicate the layer. So I'm going over here. I will rename my layer. This will be a hazard map for 2% probability of exceedance in 50 years. And now I have to right click again on it, select properties, and to change the values I want to see. In this case, I will select PGA 0.02. Classify, apply, and OK. Enable this layer, but again, we can't see anything. This is because this layer is not above the previous. So if I want to see it, I will do it like that. So this is for a hazard map with PGA values for 63% probability of exceedance in 50 years. And this is a map for 2% probability in 50 years. Would someone like to tell us why do I see that difference? Why is this map, this map has different values from the previous? If you click also on it, you will see that all the PGA values are way different. Would someone like to give it a try?
Because the values of 2% probability of exceedance, we expect stronger earthquakes. And that actually, should I ask, looks like the San Andreas fault rupture?
Exactly. Yes. Actually, I haven't been there, but I think this is the San Andreas fault. So, thank you very much, Ira. I think that was the best answer. I don't have to say anything else. This is exactly it. If we want values for a lower probability of exceedance, that means that those values are more rare. More rare means higher values, so this is what we expect. We can see over here that we have the highest PGA value has a value of 1.4, and in the previous case we have almost 0.4. This is a more rare event. These are more rare events, so the PGA values are higher. Of course, we can do exactly the same for the spectral acceleration values, but you can do it on your own if you want. Nothing will change, just the values. And now we can continue, if you don't have any other questions for the maps, with the other questions. The next thing we want to do is to produce hazard curves, but this time for Los Angeles and San Francisco. Would you like to continue? Okay. So I'm closing QGIS. We won't need it for now or totally, I think. So we want to produce hazard curves for the sites of Los Angeles and San Francisco. What we have to do now is to open the file we used before, not this, for the classical PSHA analysis. And this was for the hazard maps. If we want, we have to go on the job.ini file and to make some changes. If you see, before we used a region, an area polygon, a polygon for California. Now we have to make these lines comments. We won't use them. So use the hashtag sign and make them comments. We want to calculate the seismic hazard in two sides. So we will use the second option and we have to define the coordinates. Over here, in the description of the example we are doing, we have the coordinates of those two sides. So I can copy paste them. You see that these coordinates are latitude and longitude. But in QGIS, I have to give longitude first. So copy paste them. And write them over here. Okay. Not with Los Angeles. They must not be separated by comma. The next point must be separated by comma. So I'm giving the longitude and the latitude. I did exactly what I told you not to do. I have to give first the longitude and then to give the latitude. I'm so sorry for that. Copy paste it. and then give the coordinates. I think I missed a minus. And then the coordinates for San Andreas area, site. Okay. Okay, now we have defined our sites, Los Angeles and San Andreas. And the other thing we have to change is that we don't want to produce hazard maps, so please change hazard maps to false. We want hazard curves and the uniform hazard spectra for 63% and 2% probability of exceedance in 50 years. If you see the description of the example we are running, it says that we can use a series of intensity measures of PGA, spectral and spectral acceleration at different periods. So the first thing we have to do is to change also uniform hazard spectra to true. Hazard curves are already true. And we have to add some intensity measure types over here. In order to do that, I'm sorry. I will copy that and paste it under this line. I have to change the name because I want spectral acceleration at 0.1 second and do the same for all the other values I want. I think 0.1, 0.5, 0.75, 1, 1.5, and 2. So be careful these lines to be separated by a comma. Okay, paste that again. Rename it to spectral acceleration 0.5. Ah. 0.5, 0.75, 1, this is 1 second, kind of irritating I could say, 1.5, and over here I will change 1 to 2. Every line is separated by a comma from the previous, and of course the final doesn't have a comma. Right now, I think if you have done it, we're ready to run our analysis. You have to save that job.ini file, but I won't close it if you want to see it. I will open it again. Have any questions so far? Have you done that? The only thing we did so far is to change the site, the geometry of the area we want. So we used two sites, Los Angeles and San Andreas. We change the outputs we expect. We want mean hazard curves and uniform hazards. And we changed also the intensity measure types and levels. Okay, we will close that. Open the file we want, the file we have changed, we have saved them. Okay, I want to choose all of them. Send to zip, And now I want hazard, it is a PSHA analysis, but I want curves and spectra. If you have done your file, you're ready to run the analysis. Back to calculations, run a calculation, find the folder you want. Okay, I have a mistake. You see, this is the traceback I told you before. Probably something from the copy paste I did before. Okay, close that, open the job.ini file, and let me see what I have done. PGA values. This is separate. Spectral acceleration. You see something unusual? Because I can't right now. I will try it again. Okay. I will say it one more time. They forgot a parenthesis or something? I don't think so. But OpenQuake must be right. So I'm deleting this one. I will delete the previous. And I will do the same procedure. Okay, let's see what was the mistake. Have I write twice the intensity measure type? Okay. I have also another file. I can see what is the mistake. Is your analysis running? No. Yes. Okay. Let's do the same procedure again. So I have spectral acceleration for 0.1 seconds. I see that the format is okay. Then I want the same for spectral acceleration at 0.5, 0.75, 0.1, and 2 seconds period. I see that all my inputs have the same format. I think we are okay so far. Save that folder too. I don't want hazard maps. All the others must be the same. I don't want also quantile curves. And we're not ready because I didn't change the region. Sorry for that. Okay. I haven't changed the site, but I don't care now. I just want to see if the analysis is running. So send to zip PSHA And now go on OpenQuake again, run a calculation. Do you see? This is what I told you before. It gives me a traceback for. Okay, I have to change the name. So I will name it job. And now I think I won't have a problem. Okay. Okay, it is running now. Have you done that? I think you can listen to me. We won't have a problem as last time.
Yes,
So-
yes, we still listen. I'm still working on mine.
Okay, that's perfect. I have the outputs here, so there's not a problem. Okay. If you have any questions, please ask. This is what you have to do on your term project. I really want you to understand what you are doing. I guess your analysis is done, but let me find something that I want to find. This is why I should have gave a better description, but it's too late now. Okay. Okay, those are the outputs I want. We will make a break, but before that, I would like really for you to have run the analysis. So if you have any problem, to discuss that. Okay. Has anyone finished the analysis?
Yes.
Oh, okay.
Yes.
That's perfect. So if you click on the analysis, on the outputs, you will see that, oh, I just lost it again. I don't believe that. But I think okay, that was it. If you see over here, we have the outputs for the hazard curves and the uniform hazard spectra. I want you to download the CSV outputs to see what we have so far. You can download them. I have them on my computer. Would you like to have a break? Or should we continue?
Let's have a break.
Okay. Thank you very much for your answer. So, at 15 minutes, 10, 15, come back and we will see our hazard curves and our hazard spectra.
Okay.
Okay, thank you.
Angeliki, can I consume some time to see on my computer screen the issues that I have because I cannot run
Of
the
course.
lecture again?
Okay, I guess you have sent me your file.
Yes. Okay, let me. I'll try to share my screen.
Yes, yes.
Okay. So where do you want me to go to?
We are making changes only on the job.ini file, so probably the mistake must be there. Okay. Okay, this is for the second part we are making right now. For the hazard cares and okay. I think it's okay.
Do I need to, στο ίσον χρειάζεται να έχω κενά μεταξύ το spectra και το true ή όχι, δεν έχει καμία σημασία.
Δεν έχει καμία σημασία.
Okay.
Don't worry.
Okay. Οπότε, θα κάνω όλα αυτά. Ένα ζυπάκι.
Yes, zip them.
Θα πάμε εδώ, run calculation. Και μου βγάζει αυτό.
Ωραία. Πιθανότατα να υπάρχει πρόβλημα. Μισό λεπτό. Is there anyone else that has the same problem? Or should I discuss it with only George? Okay. Επειδή δεν ακούω κανέναν άλλον, πιστεύω ότι έχει θέμα το OpenQuake. Βασικά το εργαλείο που χρησιμοποιείς αυτή τη στιγμή. Ίσως μπορέσεις να το τρέξεις από το command line. Έλα να το δοκιμάσουμε. Λοιπόν, stop sharing and I will show all of you how you can use the command line in order to run it. We don't have only to use this tool you are doing so far. So, okay, I'm starting sharing. Okay, I don't want now the OpenQuake tool, so I have to the OpenQuake engine console. If you want to run the analysis from the console, you don't have to zip your folder. You have to write OQ engine run Okay, πήγαινε στο φάκελο. Go on the folder you have just made. You have a folder. It shouldn't be zipped. Other way, OpenQuake will complain. Okay.
Give me 2 seconds.
You don't have to have a folder. You have stored them somewhere. So click on Job File and click over here. Copy the path of the folder of the file and paste it over here. OQ engine run and give the file of the path of the folder of the file.
And then
before you run it, you have to add /job, the name of the job.ini file. In my case, it is job.ini. Write it. Use 2 slashes. Write export CSV. I can copy paste it and send it to you over here on the chat. Let me do that. It is easier. I'm sorry.
Στείλτε, λογικά πρέπει να φαίνονται δύο προφίλ, ένα Ζώσης Γιώργος και ένα George Ζώσης. Στείλτε στο George Ζώσης, γιατί σε αυτό το υπολογιστή έχω το...
I sent it on the chat.
Okay.
You have to change the path of the folder. Just be careful with that.
And after that, I click enter.
Yes, it will probably run.
No, file not found.
Something is missing, I see. It doesn't run me. Have you closed the black window on your OpenQuake? When you're using this, have you closed the black window?
What do you mean, the black window?
I will show you. I want to close that and open the wave view. Have you closed this window over here?
Probably.
This is the problem. You have to let it be opened.
Okay, yes.
But you can also run it from the console. Through the console.
Okay, run a calculation. I see. Oh, sorry. Seems like it's working now, yeah.
Okay, so it is running. You don't have a problem now?
Yes.
Okay, that's perfect.
Sorry for that.
Someone...
Thank you.
No problem. Someone has a problem with OpenQuake. That's why we're here, to see what is happening.
May I ask something?
Of course.
When we said that PGA of 2% probability
Yes.
has higher values than PGA of 63% probability, why the two maps were different? I mean, this 2% probability means that there is 2% probability of exceed our seismic values. I mean,
well, think of that. When we have some observed values,
yes,
if we use if the percent of exceedance of those values is lower, that means we are talking about high values. So how many times have you observed an earthquake with a magnitude 8? And how many times have you felt an earthquake with magnitude 4 to happen? The higher the values we expect are more rare to happen.
Yes.
So this is exactly with the PGA. I know what is confusing, that you're considering, yes, but now I have a 2% exceedance probability and this is lower from 63. Well, this is the probability of exceedance, exactly. So only 2% of the values have exceeded this value I'm talking about.
Okay.
It is simple, but it needs some time in order to get that.
Okay. Thank you.
You're welcome. Okay, if you want, we can continue. I guess you have downloaded the outputs for the hazard curves and the hazard spectra. I guess we should start from the hazard curves to discuss the outputs. If you open that folder, you will see that we have hazard curves for all the intensity measure types we asked the outputs for. PGA, spectral acceleration, accelerations at different and spectral acceleration at different periods. So let's open the PGA hazard curve. We have to change a little bit the outputs because we can use them that way. What I am doing is that I always delete the first row. I don't need that. It says me something about the analysis, so that it is the mean hazard curve for the investigation time of 50 years and PGA values, but I know I have them on my folder too, so I delete the first row. And now I want to, I want to change my comma separated values to columns. That's why, as we saw the last time, I'm going over here on data and select text to columns. This is delimited. I click on next. I use comma as a delimiter. Click on next. And if you remember, I'm using dot as a decimal separator and comma as a thousand separator, so I have to change it. Click OK and finish. Now, these outputs are useful for me because I can work with them. The first two columns are not necessary. We won't need them to plot our hazard curve, so I delete them in order not to be confused. And what we can see now is that we have 3 rows. The first row, if you remember, gives us the set of peak ground acceleration values. For each peak ground acceleration value, I have the probability of exceedance in 50 years for Los Angeles and San Francisco. So each row is for one of the sites I have give as an input in OpenWake. In order to plot the hazard curves for each site, we can use those values, but what we can do is to select the first row, go here at home and press the option replace. Replace is the text that says power with a slash. To replace it with nothing. So I'm just pressing replace all. The other thing I see is that that I'm using a comma. I can use it, so I replace with the decimal parameter. And now I can see that are numbers and I can use them. Right here I have a problem. Excel did what I told him, what I told to do. So I'm using a comma. And if you see, the outputs we expect are really low values. And over here, I'm seeing something unusual. OpenQuake does that sometimes, so I will just delete the last columns because my outputs are not real. And now we want to plot the first curve. I have to insert a scatter plot with smooth lines, and on the x-axis, I will use the PGA values. On the vertical axis, I want the probability of exceedance in 50 years. If I click OK, then those are my outputs. But this curve doesn't look like this one. If you look carefully, those two axes are logarithmic. So this is what I'm going to do over here. Select the axis, right-click, Format Axis, and use this option that says Logarithmic Scale. it starts to look a lot more the previous, but I have to change also the vertical axis. Change again the axis to logarithmic scale, and if you see, well, this looks like that curve that I saw previously. But on the axis, this one, I have the probability of exceedance in 50 years. What if I wanted to use the mean annual frequency? So over here I have PGA values. Here I have the probability of exceedance. I will write 50 years. I'm sorry. And over here, I want the mean annual frequency. No. Over here, I want the mean annual frequency. In order to get the mean annual frequency, I will use the equation I showed you previously. This one that says mean annual frequency is minus the natural logarithm of 1 minus POE over the investigation time. So let's write it together. It is minus ln 1 minus the probability of exceedance in 50 years over the investigation time that it is 50 years. If I do that for all the probability of exceedance values I have, now I have calculated the mean annual frequency for Los Angeles. If I want, I can plot also this curve. So I will copy paste that and I will just change the vertical axis. If you want, you can do it also from here to insert a new curve. Select the values, and this is the curve that shows the mean annual frequency. If you see, that was probability, and we can understand that because the highest value is 1. We wouldn't expect something different. But mean annual frequency doesn't saturate to 1. It has lower values. As we said before, for low values of probability, mean annual frequency has the same values with annual probability. In this case, we have probability of exceedance in 50 years, and this is the mean annual frequency curve. If you want, you can format the axis to be on the side, but we won't do that now. So far, we have done that. If you want, you can do the same for PG. We have done that for PGA hazard curves. You can do the same for spectral acceleration at different periods. And if I wanted this whole plot, how would I do that? On the same graph, I would use the spectral acceleration values for all the other periods, and for PGA, because PGA is spectral acceleration at 0 seconds. You know that? You don't have a problem. Okay, so far. Is it something that you don't understand? You have to do that. That's why I'm asking. I don't want to iterate you, but this is what you have to do, and you will do it for your term project. Over here I have PGA. And here I have POE. Also here I have MAF. Horizontal axis, I have PGA values also. Okay, have a problem, I won't save my results. Actually, I will. Okay. I think you hear me. Next thing we want to do is to see our hazard curves. So let's see them. Irritating. I delete the first row. And as we did before, I want to change the comma-separated data to columns. I use a comma delimiter, and I'm changing with commas. This, and I will delete also the coordinates over here. And what we see? We see some outputs for 63% and 2% probabilities. Let me change it a little bit in order to understand. So, the hazard curve, a hazard spectrum, I'm sorry. So a hazard spectrum is the spectral acceleration for a range of periods under a constant probability of exceedance. Couldn't I do that only using the outputs from the hazard curves? Of course we could. If you see, over here we have some plots. Let's look at the blue one. This is referred to 10% probability of exceedance. So if I wanted, I could go over here on my hazard curves, and if I had the outputs for 10% probability of exceedance in 50 years, not the annual probability, this axis would say 10% probability of exceedance in 50 years. To say, I'm sorry, I have to change it. I made a mistake. This axis would say probability of exceedance in 50 years, not 10%. And if I wanted 10% probability, I would go over here and I would hit this curve. This is for PGA. So this value over here for 10% probability of exceedance, not annual, but in 50 years, would be that one over here. And taking this and going over here, I would have this spot over here. This is spectral acceleration for 0 seconds period. This is my PGA value. So doing the same thing for each hazard curve, I could take this plot. Be careful, constant probability of exceedance. So forget math. Again, probability of exceedance in 50 years. Go over here, and for every plot that is referred to a spectral acceleration on a given period, I could take the values and plot my uniform hazard spectrum. Right now, OpenQuake gives me the outputs, so I don't have to do that. Over here, we see the spectrum, the uniform hazard spectrum for 63% probability of exceedance in 50 years for Los Angeles and for San Francisco. The same for 2% probability of exceedance in 50 years. Over here, I see that I have the periods. I won't change it as I did before, so I will just write the range of periods I have. It is 0.1, 0.5, 0.75, 1, 1.5, and 2. And what I can do now is to insert a plot as I did before with smooth lines. And on the horizontal axis, I will have the range of periods And on the vertical, I will have the spectral acceleration values. You know what a spectrum is, but I'm just saying it in order not to have a problem. I will change the name, I forgot to change it before. This is a uniform hazard spectrum for 63% probability in 50 years. And now I want to plot also for 2% probability in 50 years. So what I have to do, I will move it a little at the left. And I will also add for the same side the uniform hazard spectrum for 2% probability in 50 years. I'm using the same period range, and now I will use those values for Los Angeles. Of course, as we expected, and as we discussed earlier, for 2% probability of exceedance, the values are way higher. Any comments? Any questions? Let me check that you hear me. I think you hear me.
Yes, we can hear you.
Okay. Pretty much that was our example. We did the hazard maps for California, and then we saw for two sides the hazard curves and the uniform hazard spectra. Of course, if we use more spectral acceleration values at different more periods, we would have smoother lines. But this is okay. This is an appropriate number of points. If you use lower range of values, the output wouldn't be that good, I think. And that was our classical PSHA analysis. If you want, you can repeat the same calculations, exactly what we did today, for another VS30 value. And if you have a problem, you can send me an email. You can ask me anything you want. And as you have understood, now you are ready to start your term project. If you don't have any questions on that part, we can move a little more to disaggregation analysis. Okay. I will also save that. We might need it later. Okay. And the next thing we will see is disaggregation or deaggregation. I have heard both terms, but I use disaggregation. So far, in our classical PSH analysis, we have used all possible seismic sources and all magnitudes to calculate the seismic hazard in a region or a site we want. What if we wanted to know which rupture, so which combination of magnitude and distance from the site we study is the most critical, is the one that contributes the most in our probability of exceedance values? In this case, we can run a disaggregation analysis. So what we are doing, first we are running the classical PSHA analysis, and then we will tell OpenQuake to calculate the contribution of its combination of distance and magnitude that we want, the range of distances and magnitudes that we want of our analysis. So here you see for different magnitudes, we specified with bins, and for each rupture, the contribution to our analysis outputs. If you remember from last time, Dr. Van Vaticos told you about Bayes' theorem that follows the total probability theorem we already saw. This type of analysis is super easy. You will see that. So let's see what we expect. It would be nicer if we downloaded the disaggregation file we will run. So please download from my courses that file over here that says disaggregation and see what we expect and what we will do. Okay, I'm leaving you a few minutes to do that. You see that over here we have all the previous files we used before. This is because first we are running a classical PSHA analysis. If we open the job.ini file, you will see that, of course, every time we're giving the description, we will run a disaggregation analysis for San Francisco this time. And we have to set the calculation mode to disaggregation. This is another type of analysis, that's why we do that. Ignore all the other things. We give as inputs the search model, logic tree, and the ground motion prediction equation. This follows the logic we saw before. When we run our classical PSHA analysis. So this is the first thing we do. Give the inputs. The investigation time is 50 years. The intensity measure type I want to study this time is PGA. Let me read the description of what we will do. Is to run. Okay, this is for Los Angeles. We will run for San Francisco, potato, we don't care. We will run a disaggregation in terms of magnitude and distance. You can also use different parameters, but in this case, we want a plot that shows only the contribution of magnitude and distance. For PGA, ignore SA for now, we can do it later. For 10% and 2% probability of exceedance in 50 years. So let's go back to our job.ini file. We have PGA values, we ignore spectral acceleration for now. 50 years. Over here, we have to specify the poised disaggregation output. We want 10% and also we want 2% in 50 years. So we have to change that. We are using a magnitude with bin distance of 0.5. So if you see over here, this is what we have done. We have magnitudes from 4.5 to 8.5 with bins of width of bins of 0.5. We have a width of bins for distance of 10 kilometers. This is 5, but we are using 10. Those two lines, you have discussed them with Dr. Van Vaticos the last time. And also we want to extract outputs for magnitude and distance. So we want magnitude and distance. The only thing we changed so far is that we added also one probability of exceedance we want the outputs for. So save that file. And now we have again to zip it and to run the analysis over here. Open your OpenQuake, run a calculation, find the folder. Let me find it. And the analysis will run. It is really fast, but the thing we have to see is how we can plot those outputs. Okay. Something is wrong. Let me see what is happening. I forgot something, so I will delete this file, open the job.ini file, and let me see what have I forgot to say. Is your analysis running?
No.
No.
No. You got a traceback too. Okay. Let me open the other file I tested yesterday. So over here, ignore that. Okay, I forgot to use that line. I'm sending it on the chat. Give me a second, please. Where is the chat? Okay, ignore that chat. Please add this line I just sent you under the post disaggregation command.
I think we had this line.
Okay, you have it. Okay, I'm so sorry.
I don't think we have the SA1, the second line. That's the one we're missing.
You can ignore it for now. It is nothing important. We will just save the spectral acceleration values. If you want, you can repeat the analysis later. It is not something special for now. So I will run the analysis. If you have that comment, why your analysis is not running? Suspicious. I think mine is running okay.
I think we had a comma between 0.01 and 0.2.
Okay. Oh God, again. I don't believe that. Starts to drive me crazy. Where did you have your comma? I have the site over here.
Between 0.1 and...
Πώς disaggregate.
Yes.
Okay, yes, this is the problem. I'm so sorry, I forgot it. You don't need the comma over here. Yes, you're totally right. So just run the analysis again without that comma. Did you see what we have just changed? Over here at post disaggregation, we don't need a comma. Delete that. I'm so sorry. I hate Python. Save that file. Zip the folder again. And now I guess we are ready to run the miserable analysis we are trying to run. Okay. Oh God, I don't believe it. I'm so sorry, seriously. I don't know what the problem is right now, but we can find it. I will download again the analysis. It is probably something that we can spot right now. Let me open the job.ini file. Over here we have that. The only thing we changed was the poise disaggregation and nothing else, I think. So I will try to run the analysis.
Λείπει είναι μόνο στο post disaggregation το 0,1. Λείπει ένας αριθμός. Sorry, because I speak.
Thank you very much. You don't have to apologize. Thank you. I just can't see it. Over here, you mean?
Yes.
Before or after?
Before you have another number.
Yes, I know, but I want to just run it over like that in order to see what is the problem. This is as I downloaded from my courses. Okay, let me see. So if this will run, we will just download it again from my courses and run the analysis only for 10% probability of exceedance. I think I have an older version of OpenQuake and something must have changed. I don't know what this might be. Okay, no mag 7.75. Okay. Let me check something. 0.5. Okay. I think that right now something is missing. I don't just think that, I'm sure something is missing. So I will have to check it. And if you want, I can ask Dr. Van Batikos to give us 10-15 minutes from next lecture in order to visualize those outputs with Excel. I'm so sorry for that mess. I don't know what is the problem right now. I apologize again. I'm so sorry, seriously. If you want, we can stop the lecture over here. I will find the problem and I will tell you next time what was the problem we are facing right now. Are we okay?
Yes, okay.
Since we have some time, I'm sorry again. We can discuss something that you don't understand on the previous calculations or on disaggregation analysis that we didn't discuss now. It's something that you don't understand? You have any questions about? I don't know what is missing. I think over here it has a comma. I don't know what's the problem. So should we stop here and continue for a few minutes next time?
Yes.
Yes.
Again, I'm sorry for that mess. We will solve it next time. Thank you very much. And if you have any questions, I will send you my email again. And you can ask me whatever you want. I am sending it on the chat right now. If someone wants to start the term project, you can. And we can discuss also on that few minutes the next time your questions and whatever you want to ask me. Thank you very much.
Excuse me, Angeliki.
Yes.
Before we close, you said that we can start the term project. I don't know, has anyone received an email back
No.
with an answer that Are these
Okay,
fields research okay?
when Dr. Vamvatsikos does that, if you
Okay,
have
okay,
said,
thank you.
okay, I'm sorry, I'm taking it back. When Dr. Vamvatsikos confirmed that you have choose your settlement that you want to study, then it's time to run your analysis. I mean that now you have the knowledge and the tools to do that. Thank you very much saying that.
No, thank you. No, it's okay.
Thank you very much. If you have any other questions, if you don't have any other questions, I think over here, documents, you can read what you have downloaded, the term project, what we're asking you to do. I mean that when you choose the settlement you want, and when you are able to count, you can go on Google Maps and probably categorize the buildings you have. You will discuss that with Dr. Vamvatsikos also. You're able to perform the analysis of the classical analysis for the third question and the disaggregation analysis for the fourth question. So these two questions are what we did today, classical PSHA, and what we are going to do next time is disaggregation analysis. The other part will be on the following lectures. Okay?
Okay, thank you very much.
Okay,
Thank you very much.
Okay, thank you.
Thank you.
Next time,
Have a nice
I
day.
will tell you where the problem was and we will be able to run our disaggregation analysis. Thank you very much for the understanding, and we will talk again next time. Thank you very much. Goodbye.
Bye.
Thank you, bye.
Bye.
Bye, have a nice day.
You too. Thank you very much.